Practical Machine Learning with Python. 6.4 Hierarchical Clustering, offered by Stanford Crowd Course Initiative. We can see the familiar introduction to algorithms for clustering. The hierarchical clustering approach is the most used and typical clustering analysis approach by partitioning datasets sequentially, constructing nested partitions layer by layer by grouping objects into a tree of clusters. We don't need to know the number of clusters in advance. The basic information is the distance matrix as clustering criteria. Two strategies, agglomerative versus divisive. Agglomerative is a bottom-up strategy. Initially, each data object is in its own atomic individual cluster. Then merge these atomic clusters into larger and larger clusters. Divisive algorithms switch a top-down strategy. Initially, all objects are in one single cluster. Then the cluster is subdivided into smaller and smaller clusters. We can see an image for hierarchical and partitional point of view. Hierarchical clustering is designed by a dendrogram, branch, leaves, with this formula for number of dendrograms in a tree with n leaves. Bottom-up agglomerative focus starting with each in its own cluster, we find the best pair to merge into a new cluster, repeating sequentially until all clusters are fused together. Beginning with a distance matrix. The agglomerative strategy starts with each item in its own cluster, finding the best pair to merge into a new cluster, repeating sequentially until all clusters are fused together. We have repeated. Considering all the possible merges, only choose the best. Bottom up. Consider all the possible merges and choose the best. One level up. Consider all the possible merges and choose the best. One level up. Consider all possible merges and choose the best. This is the bottom up strategy. But how to compute distances between clusters rather than objects? We have the distance matrix, but distance between clusters? We have measures for cluster distance. The first is the single link. Is the smallest distance between an element in one cluster and an element in the other cluster. We compute all the distance, we select the minimal. The second measure, the complete link, is the maximal. We find the largest distance between an element in one cluster and an element in the other cluster and select the maximal. The evident third approach is average. Cluster distance measures average is the average distance between elements in one cluster and elements in the other clusters. And the agglomerative algorithm is designed in this flow chart. We can see in 6.4.b an practical application of this flowchart. As a summary, we can see that hierarchical algorithm is a sequential clustering algorithm using distance matrix to construct a tree of clusters. Their graphical representation is a dendrogram. The hierarchical representation without the need of knowing number of clusters, and we can set termination condition in every moment. The major weakness of agglomerative clustering methods are we can never undo what was done previously. Sensitive to cluster distance measures and noise and outliers, and the complexity made less efficient. We can compare hierarchical clustering with k-means, the two major algorithms. K-means clustering produces a single partitioning. Hierarchical clustering can give different partitionings depending on the level of the resolution we are looking at. K-means clustering needs the number of clusters to be specified. Hierarchical clusterings don't need the number of clusters to be specified. K-means clustering is usually more efficient runtime-wise. Hierarchical clusterings can be slow, as to make several merge split decisions. As a result, no clear consensus on which of the two produces better clusterings. Depends on situations, on datasets, on more things. Goodbye.